Good day, everyone. So this is Engineer Jana May Domingo from the College of Engineering, Summer State University. So today I am going to discuss about the chapter 3 of the differential equation, which is all about the application of first-order differential equation. So our first topic for the application of first-order first-degree differential equation is all about the growth and decomposition. So for definition, the mathematical model for the growth or decomposition can be derived from the definition that the derivative of your population with respect to time is proportional to the population. So deriving the mathematical model using the definition for the growth or decomposition, we can say that the derivative of the population with respect to time is equal to the growth or decomposition rate times the population. So the positive k will represent your growth rate, but if it is negative, it will represent your decomposition rate. PO or P sub O, the initial population at time 0 is usually given in the problem. So note that the resulting mathematical model is a differential equation. Hence, we can apply appropriate approach to solve the differential equation. So applying the differential equation to the mathematical model that the derivative of p with respect to time is equal to kp, that will give us that dp over p is equal to k dt. Integrating the equation, that will give us ln p is equal to kt plus c. Simplifying, we have p is equal to e raised to kt plus c, and that gives us the simplest equation, the simplest form of the equation, that our p is equal to c e raised to kt. So the c is the constant. So let's have an example. So unemployment rate in Region 8 is proportional to the unemployed at any time. Presently, the unemployed is 500,000. And 5 years ago, there were 350,000 unemployed. When will the unemployed double its present count? How many unemployed 2 years ago? Solving for the So for the solution, we can start by identifying the given and the missing in the problem. So you can just write down a table for your missing and given datas, and then setting your missing data into variables like this one. So I represent the missing variable time for the first problem as t sub 1, and I set my problem number 2 variable missing data as p sub 1. So the t sub 1 represents the time the unemployed double its present count, and the p sub 1 represents the number of unemployed 2 years ago. So the next part is to solve for the c and k in order to create the mathematical model for the problem. So we actually have the formula for the decomposition or growth rate as p is equal to c e raised to kt. So we can first solve for c by using the initial condition when t is equal to 0 and substituting the given when time is equal to 0, the population is equal to how many number of unemployed. So in the problem, t is equal to 0, your population is equal to 500,000. So substituting that to the formula, we will get our c. Our c is equal to 500,000. And then, attaining C, we can also now solve for our K by using the second given condition, in which we have 350,000 as population and our time is 5 years ago. So substituting that to the formula, we will have our K as 0.071. Attaining the value for the C, we can now proceed to the general solution for the given problem, and that is P is equal to 500,000 times e raised to 0.071 t. Now, attaining this general solution for the problem, kahit po anong nawawalang variable dyan, we can solve it using this general solution. So, we just need to substitute the given and solve for the missing. So, for the problem number 1, we have, when will the unemployed double its present count? So, note that your present time is t is equal to 0. With a present population or unemployed of 500,000. So if we double the population, that is actually equal to 1 million. So substituting that to the general solution or the general mathematical model, we have P is equal to 1 million. So 1 million is equal to 500,000 e raised to 0.071 times t sub 1. So calculating for the value, so you can just, or you can directly use your calculators to solve this problem. You will have your t sub 1 is equal to 9.76 years. So next. So the second problem is how many unemployed 2 years ago. So this is our mathematical model for the problem. Substituting the given, which is t is equal to 2, we will have p sub 1 is equal to 500,000 e raised to 0.071 times negative 2. So we use negative sign because it is past. So if the problem, if the time asked is, if the time given is going to the future, we will use positive sign. But if it's going to past, we need to use a negative sign. So our P sub 1 is equal to 433,810. So the next topic, or the next application of the first order differential equation, is the Newton's cooling law. For definition, we can actually get the mathematical equation or mathematical model by the definition that the derivative of the temperature with respect to time is proportional to the quantity of temperature of body minus the temperature of medium. So that gives us the mathematical model for the Newton's cooling law, that our derivative for the temperature with respect to time is actually equal to the negative proportionality K times the quantity of the temperature of the body minus the temperature of the medium. So the T sub B represents the temperature of the body at any time T. T sub M represents the temperature of the medium at any time T. And the derivative of T with respect to time is the rate of change of the temperature in the body. And K is equal to the proportionality constant, where the negative sign denotes the body is being cooled and the positive if the body is being heated. So the differential equation can actually be solved by knowing that the temperature of the medium is constant. So this is our mathematical model. So to solve for the differential equation of this model, we just need to use the variable separable, and that will give us this equation. And solving, simplifying, we will get that the temperature of the body is equal to the temperature of the medium plus C e raised to negative kT. So let's go to our example. So we have the metal bar at a temperature of 100 degree Fahrenheit that is placed in a room at a constant temperature of 0 degree Fahrenheit. If after 20 minutes the temperature of the bar is 50 degrees Fahrenheit, find the time it will take the bar to reach a temperature of 25 degree Fahrenheit and the temperature of the bar after 10 minutes. So we need to identify first what is our body and what is our medium. So in this problem, we have the metal bar as our body and the room as a medium. For the solution, we need to identify first all the given and the missing in the problem. So writing it down in a table, that will give us this table, wherein the T sub 1 is the time it will take the bar to reach the temperature of 25 degree Fahrenheit. And the T sub B1 is the temperature of the bar after 10 minutes. So for solving for any temperature problem or any Newton's cooling law problems, we will be using that the temperature of body is equal to the temperature of the medium plus C e raised to negative kT, wherein to attain the general solution or the mathematical model for the problem, we also need to solve for the C and K like for decomposition or growth rate. So solving for C when T is equal to 0, we have the temperature of the body equal to 100 degree Fahrenheit and the medium as 0 degrees. So substituting to the equation, you will get this equation. Solving, you will have your C is equal to 100 degree Fahrenheit. So we can now actually solve for the K also. So substituting the second condition wherein in time 20 minutes, you have the temperature of the bar equal to 50 degree Fahrenheit. So solving for negative K, you will have negative 0.0347. So the body is being cooled down. Solving for the value of C and K, that will give us the general solution for the given problem or the mathematical model as the temperature of the body is equal to the temperature of the medium plus 100 degree Fahrenheit times e raised to negative 0.0347 T. So we can now proceed in solving the problems. So for the time it will take the bar to reach a temperature of 25 degree Fahrenheit, we have the given that our T sub B is equal to 25 degree Fahrenheit and our temperature of medium is equal to 0 degree Fahrenheit. So that gives us this equation. Solving, we will get that our T sub 1 is equal to 39.95 minutes. But next time, in the applications, if we will solve, if we have exercises, you need to use the whole value for the K. Do not round off. As much as possible, use the entire value of your K. So the next problem is the temperature of the bar after 10 minutes. So our T is equal to 10 minutes. And our medium, the temperature of our medium is equal to 0 degree Fahrenheit. So that will give us the equation that the temperature of the body is equal to 0 plus 100 degree Fahrenheit times e raised to negative 0.0347 times 10. So that will give us that our body temperature or the temperature of the metal bar is equal to 70.68 degree Fahrenheit. So the last application involves the mixture problem. So the basic mathematical model for the mixture problem is that the rate of change of the concentration in a substance inside a container is equal to the input rate minus output rate. So the derivative of C with respect to time is the concentration rate of the substance inside the container. The input rate is the flow rate times concentration. So this is the fluid that comes into the container, while the output rate is concentration times flow rate. So output rate is the amount of fluid or amount of concentration that is going out in the container. For example, a large tank is partially filled with 100 gallons of fluid in which 10 pounds of salt is dissolved. Brine containing 0.5 pounds of salt per gallon is pumped into the tank at a rate of 6 gallons per minute. The well-mixed solution is then pumped out a rate of 4 gallons per minute. Find the number of pounds of salt in the tank after 30 minutes. So solving for the mixture problem, we first identify the initial condition. So the initial condition is meron po tayong 10 pounds of salt in time 0. So inside the container, in an initial time of 0, meron po tayong 10 pounds of salt. So the C represents the amount of salt, the amount of substance, or the amount of solute in a mixture. And then, we now solve for the input rate. So input rate is equal to flow rate times the concentration. Wherein, in the problem, we are given the flow rate as 6 gallons per minute and the concentration as 0.5 pounds per gallon. Solving for the input rate, we will have 3 pounds per minute. Now for the output rate. So it is given that the flow rate is 4 gallons per minute. But what about the concentration? So in the concentration, in the output rate, we are not actually given the exact amount. We are just given the conditions. So the condition is meron pong lumalabas na fluid inside the container. And it is a well mixture. So ibig sabihin, yung lumalabas po na fluid inside the container is the initial condition that there's 10 pounds plus po yung sa input rate na pumapasok, that is 3 pounds per minute na salt. So for the concentration, we have to set our amount of salt. Since the concentration po, di ba yung concentration rate is equal to amount of the substance over the volume. So for the amount of the substance, we assume that it is C. We assume that as variable C over and volume is 100 plus 6 minus 4 times T. Bakit? So the initial amount is 100 gallons. Then you need to add also you need also to include or add the amount na nadadagdag inside the container at any time T. Kasi, as you can see, hindi po equal yung flow rate ni input pati ni output rate. So, for every 6 gallon per minute, meron lang pong lumalabas na 4 gallons per minute. Ibig sabihin po, meron pong natitira inside the container na nadadagdag sa volume ng fluid inside that container. So, we need to also add that volume. We need to also add that volume into the total volume of the container at any time t. So we add 6 minus 4 times t. this is volume. So 6 is 6 gallon per minute and 4 is 4 gallon per minute. So we need to still multiply that by T to get the volume lang. So we need to multiply it by T. So T is at any time T. So whatever T is indicated, so for example, after 30 minutes, you need to substitute that with 30 to get the volume. So that will give us the output rate is equal to 4C over 100 plus 2T pounds per minute. So we have the input rate and the output rate. So we can now actually solve for the mixture problem wherein the rate of concentration of the substance in a container is equal to the input rate minus the output rate. Substituting, we will have this equation, and rearranging and observing the equation, that is actually a linear equation, and we can solve using the linear method to get the general solution. So we have our PT is equal to 4 over 100 plus 2T, and the function Q is equal to 3. So instead of X, we have the variable T, which is the time, as our independent variable. So integrating factor is equal to this equation, and solving, you will get that your integrating factor is equal to the quantity of T plus 50 raised to 2. So applying it now to the general solution for linear, we will have this equation wherein the capital C represents the amount of salt or the amount of substance inside the container, and the small c represents the constant, the integrating constant. So we will have this equation, and then solving, we can use power rule in the integration of the equation, and that will give us this equation. And then simplifying, we will have this equation, and that will give us that our C is equal to the quantity of T plus 50 plus C times T plus 50 raised to negative 2. So this is the general solution for the given problem. So solving for C, so again, we will go back for the mathematical model of this equation. Solving for C, we use T is equal to 0 when C is equal to 10 pounds. So we will have this equation. Substituting, we will solve that our C is equal to negative 100,000. So it will give us this equation. And then, now we can find the number of pounds of salt in the tank after 30 minutes. So solving, we have these values. Your T is 30. So substituting that to the mathematical model that we have attained, we will get that our C is equal to 64.375 pounds. So my reference book is J. Perante, W. Perante, F. Gumba 2014, Differential Equation 2nd edition work textbook. So I hope you have enjoyed my lecture, and this is the end of my topic for the chapter 3. Thank you for listening.